So my name's Ollie. This is Andrew. It's great to see so many of you here. I know it's been a long day. And today we're going to talk to you about media playback on Android using ExoPlayer. In terms of what we're going to cover, we're really going to try and cater a little bit for everyone in this talk. So what that means is we're going to start with some fundamentals. So we're going to briefly discuss what ExoPlayer is. We're going to discuss some of its features. We're going to discuss a little bit about when you might want to use ExoPlayer. And we're going to go through a simple example that shows how you might be able to get started. After that, perhaps more for those who are already familiar with ExoPlayer, we're then going to ramp up quite quickly through some more advanced topics. So we'll talk about media composition, which is a new feature in ExoPlayer v2. We'll talk about some of the internals of ExoPlayer, and we'll describe a little bit about how they work and how playback actually works. And then finally, we'll build on that knowledge, and we'll start to talk about how you can really customize and fine-tune ExoPlayer to do a really good job of matching your specific use case. OK, so let's get started. What is ExoPlayer? So for those of you who aren't familiar with ExoPlayer already, it's a media playback library for Android. It works on Jelly Bean and above, and it's written in Java, so as Android developers, it's already in the language that you're most familiar with. If you want to use ExoPlayer, you include it as a dependency, just as you would include any other Java library. And it's also open source, so if you're inspired to check out our source code after this talk, you can easily do that, and the last slide of this presentation will actually have a link to our GitHub repository. In terms of features, we've come a long way since we initially open sourced ExoPlayer, which was back at Google I/O in 2014. So in that initial release, we supported Dash and smooth streaming adaptive media playbacks, primarily using fragmented MP4 as the container format. We also supported TTML captions and common encryption. Not too long after that, we added support for HLS and the MPEG TS container format, and also some additional caption formats. And since then, we've really been quite busy adding support for loads of more traditional media formats like MP3, MP4, OGG and Matroska, and so on. We also added several extensions. What ExoPlayer extensions are is a way of bringing functionality from other libraries into ExoPlayer. So as a concrete example, if you use OKHTTP as your networking stack for the rest of your application, you might actually want to use that exact same networking stack for media playbacks. And you can do that with our OKHTTP extension, which allows you to use that exact same network stack inside of ExoPlayer. So this brings us up to the middle of last year. And at this point, we kind of took a step back. And we made some quite in-depth architectural changes inside the player. And we released ExoPlayer version 2. In this release, we added support for more advanced features like multi-period Dash support, gapless audio, and media composition, which is something we'll talk quite a lot about in a little while. At the same time, we tried to make ExoPlayer easier to use. So we added simple ExoPlayer, which is a slightly higher level API for using ExoPlayer, and also some playback UI components that you can use to get started really quickly out of the box. Since then, we've been adding more features. Most notably, we recently added support for variable speed playback. And we've also been building up our ability to cache media as it's played. And so this is where we're at today. And the key takeaway from the slide isn't necessarily that you should understand everything that's on it. Probably for your particular use case, you only need a very small subset of these features. The key takeaway here is really that ExoPlayer has kind of evolved into quite a fully featured media library now. And so if you have a media playback use case for Android, probably ExoPlayer is going to support what you want to do. So now we know a bit about the feature set. Let's talk about when it might make sense to use ExoPlayer, and when it might make sense to use the obvious alternative to ExoPlayer, which is Android's built-in media player API. So the first thing to note is that media player works all the way back to the beginning of Android. ExoPlayer is Jelly Bean and above only. This is far less of an issue than it used to be. And in fact, there's only around 2% of active Android devices still on earlier versions of Android. But if you really care a lot about providing continued support to that 2%, then Media Player is going to be your best bet. In terms of what use cases each of these solutions is best suited for, Media Player actually does quite a good job of simple use cases. So if you just have an MP3 that's maybe bundled in your APK, and you want to play it inside your app, then Media Player is going to work just fine for you. Maybe you're already using it, and there's no real reason why you should switch. Where ExoPlayer really comes into its own is for more advanced use cases. So specifically, any kind of adaptive streaming, including dash smooth streaming and HLS. And use cases where you really want to leverage some of the advanced features that ExoPlayer provides, like media composition and caching. Another difference that's worth bearing in mind is the way that these two APIs have been designed. Media Player is very much a black box. You don't get very much control over the inner workings of the player. And in contrast, ExoPlayer is designed really to be very customizable and extensible, and you can really dig in and start to fine-tune the various dials inside of ExoPlayer to get things working just the way you want them to. So ExoPlayer is really best if you are probably an advanced user and you want to kind of tweak these things. A final but important consideration is to consider the difference of where the player actually lives when using Media Player and ExoPlayer. So when you use Media Player, as you can see on the left here, the Media Player implementation is actually in the Android operating system, and the division here is the horizontal line that you see. So below is the operating system, and above is your application. When you use ExoPlayer, the actual player implementation ships as part of your application, and it really just calls through to some quite low-level media APIs in the platform, mainly for providing access to hardware decoders. So why is this important? Well, one reason is that Android's Media Player has actually evolved over time. So as a result of that, the behavior that you get may vary slightly from Android release to Android release. In contrast with ExoPlayer, we have an advantage that you can ship a single version of the player inside your application, and you're going to get that exact same version across all versions of Android. And this means that ExoPlayer is really better positioned to provide a very consistent experience. Another important benefit of this model is when we add a new feature, we can generally support all the way back to Jelly Bean with ExoPlayer, whereas a new feature in Media Player is only going to be available for subsequent releases of Android. An interesting example of these advantages is actually variable speed playback support. So this was supported in Media Player from Marshmallow. And recently, we added support in ExoPlayer. And because we didn't have any dependencies on new low-level media APIs or anything like that in the platform, we were able to add support all the way back to Jelly Bean. What we discovered next was that there was actually a bug in the playback rate and pitch adjustment implementation that affected both Media Player and ExoPlayer. And we were able to fix that bug again all the way back to Jelly Bean with ExoPlayer, and only in O and later for Media Player. So at this point, hopefully, you can see some of the benefits that ExoPlayer has. But you might be thinking that you would be more confident in using it if you knew that some people were using it already. And I'm happy to say that we actually use ExoPlayer very extensively in Google's own applications. So most notably YouTube, which is obviously a huge video streaming service, and also applications like Google Play Movies and Google Photos. And we've actually seen really strong adoption from the wider development community as well. So here are just some of the applications that, for some use or other, use ExoPlayer today. And it's not just a handful either. There are actually over 140,000 applications on Play Store today that are making use of ExoPlayer. If your app's one of these, then thank you very much for your adoption. And please keep sending us feedback. It's really important to us, and it actually does guide a lot of what we work on. So next up, we're going to dive into some code and show a simple example. And for that, I'm going to hand you over to Andrew.
Hi, everyone. So let's imagine that you've got an existing app, and you'd like to add an MP4 player to that app. So just showing a simple video in your existing app. I'm going to go through the minimal changes that you would need to make to use ExoPlayer. So the first step is going to be to add a dependency on ExoPlayer. And there are two main options here. you can either bring in the whole of the ExoPlayer library, and that will include support for adaptive streaming formats like Dash and HLS. And for that, you can use this line in your build.gradle file. This is kind of the kitchen sink option. So the alternative is that you can just pick and choose the specific modules from the ExoPlayer library that you need. So for this example, I'm going to add a dependency on the core library, which contains the main player, obviously, and also support for regular media files like MP4s and MP3s. And there's also a dependency here on the UI library, which brings in simple ExoPlayer view, which is a minimal but customizable player view that you can put in your app. OK, so once we've added the dependency, the next step is to add some code snippets to your activity, which will create the player and use it. So we have this ExoPlayer factory, which has several methods for creating player instances. And this is the easiest to use one. It takes a context and a track selector. And for this simple use case, we can use the default track selector, which has sensible defaults for almost everything you'd want to do. Once we've created the player, the next step is to drop a view into your app's layout, and then bind it to the player by calling the setPlayer method. Now, most importantly, we need to tell the player exactly what we want to play. And for this, we're going to use a media source. In ExoPlayer, everything that you can play is a media source. It's responsible for loading the media and providing it to the player. So we're going to create an extractor media source, which has support for regular media files like MP4s, MP3s, and Matroska files, and so on. So you pass that to the prepare method, and then we call setPlayWhenReady to tell the player that as soon as buffering is completed and playback can begin, then playback should start. And finally, it's very important that you release the player when playback is complete, because the player holds system resources like codecs, and it uses memory for buffers. So these code snippets would generally go in activity lifecycle methods in your app. OK. So this is a video of what you get. I've got a nice video of the skyline of London. And you could see there that it had basic playback controls like a play and pause button and a seek bar. So if you'd like to try this out, there's a code lab being published as part of I/O, which you can go and try out. And there's also a developer guide on our project page, which will walk you through these steps. OK, so as I mentioned, everything that you can play is a media source. And it's responsible for loading media for the player. And in that example, we used extractor media source. But there are actually other more advanced media sources available. So you may have heard of Dash, which is a specification for streaming, which allows for adaptation between qualities to handle varying network conditions. And we provide Dash media source for support for Dash. We also have a HLS media source for supporting HTTP live streaming, and a media source for smooth streaming. And with our recent V2 release, we've also added a new category of media sources, which are designed for composition. And by composition, we mean joining together other media sources. Why would we want to do this? Well, I'll go through an example. So let's say we've got a video that we want to play, and also some subtitles, which are in a separate file, an SRT file. In that case, we can create an extractor media source to load the video, a single sample media source, which is going to load the SRT file. And then we're going to play these subtitles alongside the video. Now, you could try and do this yourself by looking at the player position and synchronizing the playback position with the subtitles that you're showing. But this is actually quite difficult to do in general. It's much easier to use a merging media source. And the merging media source just takes the video you want to play and the subtitles and handles everything for you. So it will handle synchronization, and then they'll be shown in the player. Another time you'd use composition is for playlists. So in this case, say you have an album of MP3s that you want to play back to back. You could try and do this yourself by playing the first stream and then swapping out the source for the next one. But that's not going to be great, because the player is going to buffer when you swap out the source. So we've added a concatenating media source, which takes a list of sources that you want to combine together. and then plays them back to back with a consistent buffering policy. So if you tell the player to have 3 seconds of media buffered at all times, then it will ensure that that is the case even across transitions from one source to the next. And this also supports gapless playback metadata, so you can play that album of MP3s with completely seamless playback. And also, composition is very flexible, so we can combine those two examples that we saw. So we can concatenate a video with the merged source that we created earlier that had subtitles. And if you do that, this is what you're going to get. So the first video plays, and then when the first video completes, we get a seamless transition to the next video, and you can see the subtitles are coming up, as we'd expect there. OK, so this is great. We can play these compositions of media. But then, so we implemented this, and then we thought, hold on a moment. We've got this seek-to method on the player, but now we've got playlists that we want to play back that have multiple sources. And a timestamp is not really enough information to know where you want to seek to anymore. So we thought about this, and we thought about other types of media source you might want to play, like live media sources. And we realized that we really need a way to expose to the app the structure of the media source and what media is available. So to solve the issue of needing to have know which source you want to seek into, we added a parameter that tells the player which of the sources in the playlist you want to seek to. And then we thought, we're going to need a description of the media available. So we added a new data structure called a timeline. And a timeline basically is a representation of all the media that is available in a media source. And it consists of a list of windows. Each of those windows corresponds to one item in a playlist, and it describes which parts of the media you can seek to at any given moment. So I'm going to show an example of this to make it a bit clearer. So let's imagine we've got a single source where you can seek anywhere. The red line here represents one window. The dot at the left-hand side represents that the default start position for this media source is at 0. So when the player reaches this source, if it's in a concatenation, then it will go to time 0. And the window extends all the way to the duration of the media source. A more interesting case is if you concatenate two sources together. And in this case, you end up with a timeline that has two windows. And as you can see, for both windows, the start position is at the beginning of that source. What about if we have a live media source? Well, in this case, the timeline is actually dynamic. So as the live event progresses, more media is becoming available in the window. And you can see that the default position is tracking the live edge. And then when the live event completes, the default position snaps back to the beginning, so that this becomes a regular stream where playback begins at the beginning and you can seek to any position. And we can build on top of this to have concatenations of regular streams and live streams, and this works in the way you'd expect. So when you concatenate sources, you end up with a timeline that consists of the concatenation of the windows of those individual sources. So you'll see this timeline exposed in ExoPlayer's top-level API. You can get the current timeline. You can pass in a window index when you seek the player. So you can say, please seek to the second item in the playlist at a particular offset. And you can inspect details about these windows, like where the window starts and how long it is. OK, now back over to Ollie to talk a bit about the internals of the player.
OK, so as Andrew says, we're now going to dive in a bit deeper to ExoPlayer and really talk about what happens internally during a playback. And the reason that we're going to do this is that after we've talked about some of the internal components, we're then going to go on to talk about how we might customize those to very fine-tune the player to your specific use case. So here we have an ExoPlayer, and it's just received its media source that it's going to play back. So what are the important internal components? Well, the first important component that we should mention are renderers. A renderer is responsible for rendering a single component of media. So a video renderer will decode and display just video, and an audio renderer similarly will decode and output just audio. And a real ExoPlayer instance will have additional renderers for things like text and metadata as well, but we're going to omit those from this diagram just for simplicity. Another component that's important is a track selector. A media source may actually expose multiple tracks that could be played back by the player. Particularly if you have a Dash or HLS adaptive playback, the media source may actually expose multiple video streams at different resolutions, and maybe multiple audio languages as well. And it's the job of the track selector to select a subset of those tracks that should actually be buffered and played by the player. The last component that we need to talk about is a load control. A load control actually has two jobs. Its first job is to tell the media source whether it should be buffering at this point in time. And this is indicated in this diagram by the green dot on the left-hand side. Since we haven't started playback yet, we don't have anything buffered, and therefore it's green to represent that the media source should be buffering. Its second job is to tell the player when playback is actually allowed to start. This is represented by the right-hand side dot, and because we don't have any media yet, it's obviously too soon to start playback, and therefore it's red. One other component that we should mention are data sources. Media sources use data sources to load the actual media that they're going to provide to the player for playback. OK, so I've kind of given you some major components, but let's talk a little bit about how these components actually interact during a playback. Well, we haven't buffered anything yet, and load control is telling the media source that it should be buffering. And so the media source is going to start loading data through its data source. And after it's loaded enough media, probably not very much, just the header for a normal media file, the media source is going to be able to work out what tracks it can actually expose to the player. And it does this by exposing something called track groups. Now, we know that the track selector is the thing that's going to choose which of the tracks to actually play. But the track selector needs something else. And the reason it needs something else is that different devices have different capabilities. And in particular, the video renderer may only be able to decode up to a particular resolution. And so even if the media source exposes a 4K video stream, if you're on a low-end device, it's not going to make sense for the track selector to actually choose that stream. And the way we represent these kind of capabilities in the player is we have each renderer expose something called a renderer capabilities object that describes specifically what it's actually able to handle. So what happens next is that the track groups and the renderer capabilities are fed into the track selector. The track selector does its magic. It produces a selection. And that selection goes back to the media source. At this point, the media source knows what it's going to buffer, because it knows what the track selection is. And so it allocates some buffers. Of course, we still haven't actually loaded any useful media for playback. The load control is still telling the media source to load. And therefore, the media source continues to load data, and it starts to fill its buffers. And what you can see here is that as soon as these buffers start to get full, the renderers actually start consuming from those buffers and feeding that media data through their decoders, getting ready for playback. So at this point, we have some media buffered. The renderers have decoded a bit of media, so they're kind of primed and ready to go. And so the load control may, at this point, actually start the playback. So that little red circle has gone green. And of course, the media source is continuing to buffer. And at this point, we've actually buffered quite a lot of media. So these buffers on the left-hand side are quite full. Of course, we don't want to buffer arbitrarily far ahead. So the load control may stop buffering at this point. Because playback's continuing, the renderers are still consuming. And therefore, these buffers are draining back down to a lower level. Of course, we don't want the buffers to run out, so the load control might toggle buffering on again. And so you see this pattern emerging of data being pulled through the data source into the media source and out to the renderers. One additional complexity to keep in mind when you're thinking about this is that, as Andrew said, a media source can actually be a concatenation of, for example, different videos. And those videos may have a different selection of tracks available. And so as this process is continuing, you may actually get additional track selections taking place at the same time. And so here we have the playback continuing. The buffers are filling up and draining down, and you see this pattern of data being intermittently read through the data source and continuously consumed by the renderers. OK, so now we know a bit about actually how the important components work during a playback. Let's talk a little bit about how we might customize those internal behaviors. So here is a code snippet that Andrew showed you earlier. We're creating an ExoPlayer with ExoPlayer Factory. But there are actually more complicated methods for creating an ExoPlayer. This is one of them, and you can see that what we're injecting into this player instance are exactly the components that we've just been talking about. So the renderers, a track selector, and a load control. And here we're just inserting default implementations. So let's look at how we might fine-tune the player by pulling one of those out. So we'll look at the load control, and here we're still using the default implementation. But we can actually pass some variables into the constructor to manipulate its behavior. So this default load control is saying that it wants between 15 and 30 seconds in the buffer, and it wants to start playback when there's 2.5 seconds buffered. So what does that look like in terms of wall clock time versus duration of media in the buffer? Well, the buffer starts to fill, and at 2.5 seconds, we allow playback to start, as indicated by the little orange dot. And the load control allows buffering to continue up until 30 seconds. Buffering will then be turned off for a while, and the media source buffers will drain down to 15 seconds, which is the lower limit. And buffering would then turn on again, and so you get this kind of sawtooth pattern in terms of buffering behavior. So at this point, it's probably quite clear that you can start to really influence this behavior. So you could change this number from 15 to 25 if you're not comfortable with allowing a buffer to drain that low. And because we understand how default load control works, we can show the new graph. So here, the buffer is kept more full at all points during the playback, and buffering is toggled on and off far more frequently. We could also decide we might want to be more conservative about when we allow playback to start. So we bump up the value from 2.5 seconds to 10 seconds. And again, we can understand the difference in terms of this graph. We can now take our modified default load control and inject it back into the player. OK, so what if default load control just isn't flexible enough for the actual buffering policy that you want? Well, you can go further, and you can just implement your own load control from scratch. So one of the methods that you have to implement if you do this is called shouldContinueLoading. It returns a Boolean. It's polled during playback. And this is exactly the method that's actually controlling whether the media source buffers or not. And you could implement all kinds of behaviors and logics in your own implementation. You can do similar things with the track selector as well. So in this case, we can actually get some parameters. And we can start manipulating the way the default track selector actually chooses its tracks. So here we're limiting the video tracks to SD, so 480p. And you might want to do this if you know that your user is on a metered mobile connection. And even if they have really great bandwidth, you probably don't want to use all of their data very quickly. So you might want to keep a cap on the quality that you deliver. Similarly, if you know that your user is German, you might select a preferred audio language for the case where there are multiple audio tracks exposed by the media source. And you can set these modified parameters back on the selector to actually activate this new behavior. Again, if the default implementation of track selector isn't suitable, you can go a step further and implement your own track selector. One of the methods you need to implement if you do this is select tracks. And hopefully, you can map the signature of this method back to the diagram we saw earlier. It's receiving the capabilities from the renderers and the track groups from the media source, and it's generating a selection. And of course, the same tricks can be applied for the renderers as well. Implementing your own video renderer from scratch is a pretty advanced customization, but you could do it if you really wanted to, and you kind of have a good handle on exactly what you have to do to achieve that. And you could extend default renderers factory, override the build video renderers method, and actually inject your own video renderer into the player instead of the default that would normally be created.
OK, great. So hopefully, you can see a pattern emerging in each of the examples of customization that Ollie talked about. So the first step was establishing which component in the player we need to customize, whether it's the track selector or the load control. Then you look at the API for that component and see if there's a way to customize its behavior using, say, a different parameter, as we did with load control. If that's not a possibility, then you might be able to extend or actually implement your own version of this component from scratch. OK, So I'm just going to do one more example of customization on the media source side this time. So imagine that we need to send an authorization header with each HTTP request that a media source makes. Well, we know that we're passing in a data source, HTTP data source factory. And this has a convenient method to get the default request properties. And by getting the default request properties, we can actually set a new header to set the authorization header on the HTTP requests. And once you've done that, you pass that HTTP data source factory into the media source, and that header will appear on all requests that it makes. As another example, let's say that you know that users are going to rewind videos quite a lot, so you want to add a cache in so that the player doesn't repeatedly load the same media off the network. ExoPlayer has a simple cache which you can use. And in this example, I'm passing in a least recently used cache evictor. So the way this is going to work is the cache has a maximum size, but if the media is longer than that, then when the media finishes, if they've watched the media all the way through, then the cache will actually have started to evict the very beginning of it. OK, so this cache gets passed into a cache data source factory. And it also needs to take a normal data source, which is used if there's a cache miss, and also to populate the cache. And then you pass the cache data source factory to the extractor media source. So hopefully, to make this a little bit clearer, let's see how it fits in with the player architecture we saw earlier. This cache is actually going to sit between the media source and the HTTP data source. And when the media source requests data, it's first going to look it up in the cache. If there's a cache miss, then it's going to go to the network and use the HTTP data source. Then on the way, when that request is satisfied, it's going to come back and fill in the cache so that next time the media source requests the same chunk, then hopefully it's going to be in the cache. OK, so we talked about how the kind of extreme case of customization is providing a media source or whatever that you've implemented yourself. So I'm going to go through an example of doing that. Let's say that you've got an app where you're showing some content, but now you want to monetize that content by showing ads alongside it. Let's have a think about what the timeline is going to look like in this case. Well, it may be very simple. In this example on the screen, there's just one ad at the beginning, a pre-roll ad. Or it may be more complicated. So in this case, there's a pre-roll ad and a mid-roll ad and a post-roll ad. And they kind of split up the content. So at first glance, you might think this is a place where we could use concatenating media source. But unfortunately, normally when you're loading ads, you can't actually commit to a particular ad URI until the time when you're about to play it. It's not the case that we have a list of exactly what ads we're going to play up front. So let's see what would happen if we try to use just one player with conventional media sources to play these ads. So at the beginning of playback, we get the URI for the first ad, and then we can play it. But then we know that we need to play the content, so the player is actually going to buffer when we tell it that we want to play the content instead. Then the content will play back, and the user is going to see buffering again. Then the ad, more buffering, and I guess you're seeing how this is going to work. There's a lot of buffering, and this is not a good user experience. So one way that people try to work around this is they will try and use two players. And the idea is that one player is going to play what's on the screen at the moment, while the other player is in the background buffering whatever is coming up next. So when as soon as the ad URI arrives, you can populate the background player and hopefully get some data buffered before playback begins. And in this case, playback will switch in between the ad and the content. But this solution also has its drawbacks. These two players are both going to use up memory for buffering, and they may even both be using codecs at the same time. So that's not very good. And also, this is just very difficult to implement correctly if you've ever tried doing this. So we thought about implementing a media source that's specifically designed for ads. And this media source is implemented in a slightly similar way to the concatenating media source, except that it has these playlist items which are not populated, and those are represented by the question marks. Those are going to get filled in with the ads as soon as they arrive. OK, so let's see what playback would look like with this hypothetical media source. Playback begins, and we get the first ad. then the content plays. Hopefully, we get the next ad a little bit early, and that placeholder is filled in the timeline. And if this works well, then the user is actually not going to see any buffering during playback. So as a real practical example of this, Google provides the Interactive Media Ads SDK. You may have heard of it. And we're using that for loading ads in this IMA ads media source. And as you can see, the arrow kind of highlights when the ad is loaded from IMA. And the media source is wrapping IMA, so the player doesn't need to worry about any details of how ads are actually loaded. And in this timeline, you get seamless transitions between content and ads. So we've actually pushed this to our development branch today if you want an early preview, if you want to try inserting ads in your content. It's very easy to use. So you take your content media source, and you pass it into the constructor of an IMA ads media source, along with an ad tag URI, which defines what ad playlist to load. And it also takes an overlay view group, which interactive media ads will use to show any ad user interface on top of your player, like a skip button, for example. OK, here's what you get if you try doing this. So you can see the pre-roll ad is playing. And then when the ad finishes, we get a pretty seamless transition between the ad into the content. And you can see that our playback controls have support for showing little ad markers so the user can see where the mid-roll ads are. And during this playback, there's a consistent buffering policy being applied at all times. OK, now back to Ollie to talk about some of our future plans.
OK, so before we leave you, I just want to say a little bit about the direction in which ExoPlayer is headed. Just to caveat this is no way a promise. And we're not going to put timelines on anything. But in terms of the kind of things that we're going to be looking at over the next 6 months to a year, we're going to continue to fill in the remaining feature gaps that we have in terms of becoming a really complete media playback library. One specific thing here that we know is causing a lot of you problems is proper support for offline. So this is where you actually download media to play back later. And so you can expect us to start building up support for offline during the next 6 months to a year. We're also going to continue to work on performance enhancements. And by that, I mean things like maintaining decoder instances from the platform from one playback to the next, because releasing and reinstantiating those decoders, as we do now, can be quite expensive. Another aspect of performance that we intend to look at is improved adaptive track selections for Dash and HLS and smooth streaming adaptive playbacks, and also more advanced buffering policies. So the default components that we currently provide for performing these tasks, they're pretty effective, but they're quite simple in terms of the policies that they implement. So we really want to start kind of diving deeper and doing some proper research and kind of fine-tuning these to deliver better performance out of the box. And finally, we know that the ExoPlayer API is very large and that it can be daunting to get started with and to figure out exactly where you need to dive in if you want to customize something. So we're going to work on some better documentation as well, probably starting with documenting some of the internal components that the player is using, as we described earlier. In terms of what you can do next with ExoPlayer whilst you're here, we have office hours tomorrow over in the office hours box at 9:30 in the morning. So if you have any questions for us, then please do come along, and we'd be more than happy to have a chat and to answer them. If you want to go and check out our source code, the GitHub repository is public, and you can go and have a look. And we also have a homepage, which includes a developer guide that will help you get started. And it also has various pieces of documentation, such as supported formats. And with that, I'd like to just thank you all for coming. We unfortunately don't have time for questions now, but we will probably be just down in the corner afterwards. And as I said, if you do have questions that we can't answer now, please do come along tomorrow morning, and we'd be happy to answer them. So thank you very much for your time.